Question 3, part D. We are told that a second line, L2, which is I have drawn here in orange, is perpendicular to the line AC. So you'll see here I've drawn a little right angle symbol. It's directly perpendicular, which means it's at right angles to each other. So it's perpendicular to the line AC and also passes through this point M, which has coordinates 3 and 8. And we need to show that the equation of this line is 2y plus x minus 19 equals 0. So a bit of a tough question, this one. I'm going to start with the form of a straight line. Always start here and we can work from here. Y equals mx plus c, where m is the gradient and c is the y-intercept. Okay, I'm going to have a look at the gradient first. I'm going to call it, so the gradient, actually I will call it, so gradient of L2, we're going to call ML2. Okay, because the letter for gradient is M. Now, I know that it's perpendicular to the line AC. So, if I find the gradient of the line AC, that's rise over run. Now, between points A and C, we actually drew this up here in part C. It rises 8 and it runs 4. So the gradient of the line between A and C is going to have a rise on run of 8 on 4, which is equal to 2. Now the relationship between perpendicular lines is the gradient, actually I'll draw it like this. We'll call this line 1, this line 2. The gradient of line 1, no, I'll write this another way. The gradient of line 2 is equal to minus 1 on the gradient of line 1. So that's the relationship there. You go minus 1 on the gradient of the line perpendicular. So therefore, the gradient of line L2, our orange line here, is going to be minus 1 on the gradient of AC, and therefore it's minus 1 on 2. So there's a bit to that, but we have now found out the gradient of our line L2. So back to L2, we know that y is equal to minus 1 on 2x plus c. So we've done the first bit, we now need to find what c is. To find c, I'm going to sub in point M, which has coordinates 3, 8. Whenever you have a line that passes through a coordinate, you can sub that coordinate in to find out what c is. So this is the x value, this is the y value. So 8 will equal minus 1 on 2, and our x is 3 plus c. I'm just going to move this up to give us some more room. 8 is equal to, now minus a half times 3 is minus 1.5. I'll just show you that here. So minus a half times 3 is equal to minus 1.5, which it could also be written as minus 3 on 2, but I think it's going to be easier if we keep this as a decimal. So is equal to minus 1.5 plus c. Now I'll take the negative 1.5 over to the left. Actually, 8 plus 1.5 is equal to c. So therefore, c is equal to 9.5. Good. So now we have the gradient and the y-intercept, or the c value, plus 9.5. However, the question wants it in this form here. We currently have it in the form y equals mx plus c, so we need to do some rearranging. Excuse me. Let's bring that down. Okay, I currently have a fraction here. However, the equation that I'm trying to show it, compare it against, doesn't. So a technique that I can use is just to multiply everything by 2. Multiply everything by 2. And as long as you do, as long as you multiply the left by 2 and the right of the equation sign by 2, that's fine. So this will become 2y equals minus x plus 19, because 9.5 times 2 is 19, and then I'm going to bring everything to the right and change the sign. So it's 2y plus x minus 19 is equal to 0. And I have shown that the line L2 has this equation here. It's a bit of a tricky question, that one, but we got there. That is the answer to part D, question 3.